All right, hello, Addison. Here are some of the problems that you did on that last test that you did not get correct. I copied them so I can show them to you, and we'll go through each one of them, or as many of them as we can here. Let me think. Oh, sorry, you probably can't see these questions very well, but hopefully you can kind of figure out what they say and then understand what I'm going to show you on all of these. In the first one there, it says you have a skyscraper that casts a shadow 200 feet long, and the angle of elevation of the sun is 38 degrees. So that's where you're going to have to draw yourself a right triangle. And the shadow, which would be from here to there, is 200 feet long. And this angle here is 38 degrees. And you are trying to find the height of this skyscraper. And so because you have this angle, and that side is the one you're trying to find, and this side is the one you know, that would be the opposite and the adjacent parts of the triangle with this angle, and tangent is the ratio for opposite over adjacent. So you would say tangent of 38 degrees is equal to h over 200. Then solving this, you'd multiply both sides by 200 to get 200 times tangent of 38 degrees equals h. And then you'd type that into your calculator and you would get this correct answer of 156. Now you have to make sure that your calculator is set to degree mode, or if it's not set to degree mode, you have to put the degree symbol into your statement on your calculator. To check to see if you're in degree mode, just type in tangent of 45. If you get 1 for an answer, you're in degree mode, and then you don't have to worry about that. But if you get some other value for tangent of 45, then you're in radian mode, and then you're going to have to put the degree symbol there. Now if you have a TI calculator, to get the degree symbol, you go into somewhere on your calculator, it should say angle. I think it's the shift of something. If you have like a TI 83 or 84, yes, it is the shift of the apps button. So you put in, when you hit that, then you're going to get a list of things, and the first one I think is the degree symbol. So then when you hit tangent and then 38, you would go into this angle thing and hit number 1, and the little degree symbol would appear. All right. Second question that we're going to do, this one you got right, so we're not going to go through that one. It says write an explanation of cube root of a -2. Okay, so -2 is this coordinate right here, and this angle from there to there is 180 degrees. So if you're going to try to find the cube root of a -2, so the trigonometric form of that is a -2, or no, it's 2 times cosine 180 plus I sine 180. And so then the cube root of that is going to be cube root of 2 cosine of 180 over 3 plus I sine 180 over 3. Because to do that, whatever root you're trying to find, it's cube root, so we would take the cube root of this number, and then you've got to take this angle and divide it by whatever the root is. All right. And so then the next one down says, which of the following are solutions to cosine squared of 2x minus a fourth equals 0. All right, so then to solve this, first thing you do would be to add 1/4. So then you have cosine squared of 2x equals 1/4. Next thing you do is take the square root, and then you have cosine of 2x equals plus and minus 1/2, because the square root of 1 is 1, square root of 4 is 2. And then the next thing you have to do is the inverse cosine. To get rid of cosine, you have to do inverse cosine. And so then you have 2x equals inverse cosine of plus and minus 1/2. And then at this point, now you should figure out what that is. On your calculator, if you do inverse cosine of a positive 1/2, you will get 60 degrees. Or it's a decimal, it's like pi over 3 is the radian measure. And then inverse cosine of a negative 1/2 would be 120 degrees, or 2 pi over 3. And if you look at that on your circle, that's this angle here and that angle there, which then cosine is also the same here and the same there. So then if you go from this angle to that angle, let's add 180 degrees to it. So you'd say 60 degrees plus 180 degrees times n. And then you could say 120 degrees plus 180 degrees times n, because there's 120. Now you can also, because from here to there is 60 degrees, there to there is 60 degrees also. So you could say plus and minus 60 degrees plus 180 n. And you still have 2x equal to that. Also now then you have to divide by 2, and so then x equals plus and minus 30 degrees plus 180. Or no, because we're dividing by 2. And 180 divided by 2 then is 90 n. And so in terms of radians, 30 degrees is pi over 6 plus pi over 2n plus and minus. So then you just got to figure out which ones fit that. And it's these three, which were pi over 6, 11 pi over 3, and 5 pi over 6. I think that one is. Because if you just got to see if these angles then fit in that window, which they do. All right, so then moving on to the next one, it says let f of x equals inverse tangent of x. And for inverse tangent of x, if you were to sketch the graph of it, it looks like this. From there to there, and this is a negative pi over 2, and that is pi over 2. And it goes on forever and ever. So the domain for it would be from a negative infinity to infinity, and the range is from a negative pi over 2 to pi over 2. Now this one says that the domain is from 0 to pi, and that isn't even close to being what the domain is. And then the range is all real numbers, so they've got that all messed up. So that one is false. All right, the next question says find the exact value of cosecant sine, inverse sine of a negative 1. Cosecant inverse sine negative 1. Now, This one's relatively not too bad of a question, but anytime you get something like this, dealing with any of these functions, sine, cosine, tangent, secant, cosecant, cotangent, always draw yourself a right triangle. And then, even if you draw it incorrectly, just pick your angle. And it doesn't matter which of these two angles you pick, as long as you understand that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And similarly, then let's see, cosecant is hypotenuse over opposite, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. Those things you should always know. So then this part here where it says inverse sine of a -1, and don't worry about the negative for a moment, just deal with the number. So because sine is 1, and if you're dealing with this angle here, sine has to be opposite over hypotenuse, and the ratio has to be 1. So then that means this is 1 and that is 1. Okay, so if this said inverse sine is 2/3, then in your right triangle, you would call this side 2 and that side 3, because that's what this means. It's the ratio of the sides, and you're trying to find the angle. But you really don't have to find the angle if you just draw yourself this right triangle. Okay, so now that you know that, now we need to find the third side. Well, because this is a right triangle, you can use your Pythagorean theorem, which says that a squared plus b squared equals c squared, c being the hypotenuse and a and b being the two sides. So you have 1 squared plus x squared equals 1 squared. Well, 1 squared and 1 squared is, so you have 1 plus x squared equals 1, and if you subtract 1, you're going to get x squared equals 0. So x has to be the square root of 0, which is 0. So this side is 0. And yes, I know that's not even a triangle because, well, that's where, because this value is kind of weird. But if you had some other thing, like I said, if you had this as 2 and that's 3, then to figure out this side, you would say 2 squared plus x squared equals 3 squared. And so then x squared equals 5, so x equals the square root of 5. And then you could work from there. Hope that makes sense to you. Okay, so now that you know that that is 0, then you have to find, so cosecant of that, and cosecant is hypotenuse over opposite. So cosecant is 1 over 0, which is not possible, so it's undefined. Hold it. What did I just do? I went cosecant, and the cosecant is hypotenuse over opposite, and that is not hypotenuse over opposite for this angle. That's hypotenuse over adjacent. Skip that. That would have been secant. Cosecant is hypotenuse over opposite. That's the opposite sides, which is 1 over 1, and 1 over 1 is 1. Sorry about that. Made a little mistake. All right. But that's how you can do any of those, no matter what you get for a value in here, or if this is even switched. All right. So then if we move on to the next question, we have the function f of x equals tan 3x minus pi over 2. X minus pi over 2. So period is pi. For tangent and cotangent, period is pi. For sine and cosine and secant and cosecant, this period is 2 pi. but we have something with the x, so we got to multiply by the reciprocal of what's with the x. So it's pi over 3, which could then give you this answer or that one. And then our shifting is going to be right, because it's minus in between. And to figure out your right or left shift, the x has to be by itself. So in order to get x by itself, you have to divide that by 3. So if you divide this by 3, you also have to divide pi over 2 by 3, which becomes pi over 2 divided by 3, which is pi over 6. So the whole graph is shifted to the right, pi over 6. Tangent now, when you graph it, normally it goes through this point here, and then half of the period is here, and half of the period is there. So if we don't have the shifting involved, half of pi over 3 is pi over 6, and this would be a negative pi over 6. But now we have to take this whole thing and shift it to the right. Pi over 6. So let's see. So here's where, so we have to take this whole thing now and move it so it's like that. So then our asymptotes become at 0 and at 2 pi over 6. Which is pi over 3. And then the graph goes like so. And so this one says the asymptote's at pi over 6, so that's not it. And so it's this one. Okay, that is an example of simple harmonic motion, even though that doesn't change at all. All right, which the following are solutions again. So let's see here. We have tangent square root of x minus 1 equals 0. So to solve this, you add 1 first. So now you have tangent square root of x equals 1. The next thing you do is take the square root, and tangent of x then is equal to plus and minus 1, because the square root of 1 is 1. Then to get rid of tangent, you have to do inverse tangent to both sides. So x equals inverse tangent of plus and minus 1. Now, where is tangent 1 on your unit circle? Well, tangent of 1 is there, which is at pi over 4, or 45 degrees. It is also 1 here, so plus pi n. So then you would have pi over 4, and that angle would be 5 pi over 4. And then tangent is a negative 1 here, which is 135 degrees, or 3 pi over 4. And also there, which is plus pi n. So you add another 4 pi over 4. So you'd get 3 pi over 4 and 7 pi over 4. And so these two would work. These that are over 2 don't work, because pi over 2 is this one right here, and a negative pi over 2 is that one, and it has to be those. So something over 4. All right. Okay, moving on to the next set of problems. Here you had to choose one of these for the equation. You chose 3 sine 3x minus pi over 3, or 3 sine 2x minus pi over 3. And the correct answer is 3 cosine 2x minus pi over 3. Now, so they understand the difference between the two. When you're graphing sine, sine starts in the middle and goes up and down and back. And from here to there, that's one period. And the period is from 0 to 2 pi. Usually it goes up to 1 and down to a negative 1. Cosine, on the other hand, starts at its maximum, goes down and back up, like that. And this is from there to there is 0 to 2 pi as well. Okay, well, if you're looking at this graph here, I mean, you can pick some different starting points. Like if you pick this one, then you could use sine. And then you just have to figure out how far it's been shifted that way. The amplitude, which is 3, doesn't change whether you use sine or cosine. The shift up or down, which in this case there isn't any, doesn't change if you use sine or cosine. The period doesn't change if you use sine or cosine. The only thing that changes if you use sine or cosine is how far shifted right or left it is. Okay, and the reason if you were picking this point is because now you have the sine curve. Okay. If you wanted to choose the cosine curve because your amplitude is positive, you would have to pick either this point here or that point there, because now you have one cycle going like so. Or if you chose this point out here, then you have this one going like so. To me, I think it's this one right here, because right there is a negative pi over 3, so it's shifted left pi over 3, but when you put it into the equation, remember it has to be, because it's with x, it's got to be the opposite, so it becomes x plus pi over 3. And so that's why this one is the correct one. Here's 3 sine 2x minus pi over 3. That equation, this one here, has everything the same except for it should start right there and go up and down from that point. Hope that all made sense. All right, the next one says find all solutions to the equation cosecant of x, or cosecant of x, and then 2 cosine x plus square root of 2 equals 0. Well, because you have this times this, you can set each thing equal to 0 and solve them. Well, cosecant of x is 0, so cosecant is the reciprocal of sine, so sine of x is equal to the reciprocal of 0, which is undefined. And sine is never undefined, so there's no answers for that part. Here we have 2 cosine x plus square root of 2, so then if you first subtract square root of 2, you'd have 2 cosine x equals a negative square root of 2, and then you would divide by 2 and get cosine of x equals a negative square root of 2 over 2. And then if you take the inverse cosine, you'd have x equals inverse cosine of a negative square root of 2 over 2. And cosine is a negative square root of 2 over 2 right here, which is 3 pi over 4. And then it is also right there. And that angle is 7 pi, no, not 7 pi over 4, 5 pi over 4. And then if you go all the way around the circle from here, you can get back to that angle. So it's 3 pi over 4 plus 2 pi n and 5 pi over 4 plus 2 pi n. And so then that's why that is the correct answer. Had this been a positive square root of 2 over 2, here would have been cosine negative, inverse cosine square root of 2 over 2. Now you're talking this angle and that one. So then you would have said pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. All right. Next question says, where are we at? 3, 7, negative 2, 4, then V1, V2. Okay. 3, 7, negative 2, 4. And you're supposed to take and find the V1 dot V2. And so when you do that, you take 3 times the negative 2 to get a negative 6, and then you add 7 times 4, which is 28, to get 22 for your answer. Because that's multiplication with vectors, and when you multiply vectors, you multiply, basically you multiply the x's, you multiply the y's, and then add them together. Okay, next question down says you have 3 plus 3i, and then you have that other thing, which is, 3 square root of 2 cosine pi over 4 plus I sine pi over 4. And you're supposed to take these two things and divide them. I think that's what it is. Oh no, wait a minute. Let me get rid of this. It is 7. The other one is 7, comma, cosine 5 pi over 9 plus I sine 5 pi over 9. That's what it is. All right, so first you got to take this thing and get it into this form. Well, if you graph this, 3, 3 is right there. So what's this angle? Well, since those are both the same number, it's 3 over 3. So you have tangent, inverse tangent of 3 over 3. If you were given some other value, let's say 2 minus 5i, well, 2 negative 5 is down there, so you'd say inverse tangent of 5 halves. Now, because it's 5 halves, well, 5 halves would be up here, and you're dealing with this angle here, so then whatever you get for an answer, let's say you got, well, let's see, what is that? Inverse tangent of 5 halves. 2 equals 2.5, and inverse tangent, answer. It's like approximately 68.2 degrees. Well, that's this angle going here, so we have to figure out what is this angle down there, which you could say, so then you have to always start here and go around the circle that way. So you would take 360 minus 68.2. And so then you would say 291.8 degrees would be your angle. Or you have to get it in terms of radians, so then you put pi over 180 now by it. Okay, but that's how you find it. All right, so for this one, it's 3 over 3, so this is a 45-degree angle. Whoops. So then that's a 45-degree angle, which is pi over 4. And then you also have to find what is the length of that if this is 3 and that's 3. Well, so then 3 squared plus 3 squared equals 18. So then the hypotenuse is equal to 3 times the square root of 2. So then this is 3 times the square root of 2, comma, cosine pi over 4 plus I sine pi over 4. And so then, if you're taking this divided by that, then you divide the r values out in front, 3 square root of 2 divided by 7, and then you take cosine of pi over 4 minus 5 pi over 9 plus I sine pi over 4 minus 5 pi over 9. And then you simplify that and get an answer, which, okay, pi over 4 minus 5 pi over 9, the common denominator is 36, so that's going to be 9 pi minus 20 pi, which is a negative 11 pi over 36. And so that's why it is this one right here. All right, so then it says find the exact value of cosine of 7 pi over 8. And here's where you have to use a half angle formula, because this is the same as the cosine of 1/2 of 7 pi over 4. And the formula for the cosine of a half angle is plus and minus the square root of 1 plus cosine of x all over 2. So then we would have the square root of 1 plus cosine 7 pi over 4 all over 2. Well, the cosine of 7 pi over 4 is square root of 2 over 2. So you have 1 plus square root of 2 over 2 over 2. Okay, well now this is a big pile of mess that you can't leave like that. Because when you divide by 2 here, you can put the 2 underneath this and the 2 underneath that, so you'd have 1/2 plus square root of 2 over 4. Well, to combine that into one fraction, then you got to get common denominator, so then this would turn into 4 and that would turn into 2, so you'd have the square root of 2 plus the square root of 2 over 4. And by rule, you cannot leave a square root in the denominator, so then you take the square root and put it just over that, and the square root of 4 is just 2, and then 2 plus square root of 2. So there's your answer. And it has to be a negative, because 7 pi over 8, that is somewhere in this quadrant, because from here to there is pi. So 7 pi over 8 is pretty dang close to full 8 pi over 8. This would be 4 pi over 8. And this is 8 pi over 8. So 7 pi over 8 is in this quadrant. And so that makes it negative, because cosine is negative in that quadrant. This one here, just picking out identities. You should kind of just know those identities. And that's why these two are the two that need to be correct. And then the last one, oops. Let's see, it says that you have negative 2, 5, and 4, negative 3. And you're trying to find the angle between the two vectors. Oh, there's some fine formula to figure that out, but you don't need that formula if you really don't want to use it, because you can go 1, 2, and up 5, and there's a coordinate, and now you have this angle. So you have to figure out what is that angle. Well, that angle is the same as this angle, basically, except it's 180 minus whatever that angle is. So then, this is 2 and that is 5. So then to figure out what this angle is, it's the same, like I said, the same as that. So that's tangent of the angle, call it theta, is equal to 5 over 2. Okay, now I'm not worrying about the signs of anything. So tangent of 5 over 2 is, hey, we did that earlier, didn't we? So then that means theta is approximately 68.2 degrees. Okay, well, so if this is 68.2, this angle from there to there is 180 minus 68.2, which is 111.8. All right. Then the other angle, or the other part you have is, it's 4 and down 3. Or this is 4 and that's 3. So now here, so you have that vector and that vector. So the angle you're trying to find actually is from here to there. Well, we know that, like I said already, we've already figured out that this part from here to here is 111.8. Now we have to figure out what's this part from here to here. Well, so that would be tangent of theta is equal to 3 over 4, because this is 3 and that's 4. And then inverse tangent of that. And inverse tangent of 3/4 is 36.8 degrees. And so now this is 36.8 degrees. This is 36.8 degrees. This angle right here is 111.8. And so then the angle from here to there is going to be 36.8 plus 111.8, which gets you 148.6. Well, and they went out to 2 decimal places, so you just got to make sure you round to the correct thing. Hopefully this will help you, and then you can retake this test one last time and do well on it and get yourself a grade, and then you can be done with this course, which would be really cool. Good luck with it, Addison.